Reach workshop number 3 on the topic of data analysis, where my colleague Dr. Tim Hilken will walk you through how to conduct a paired sample t-test in SPSS.
As you will likely recall, you'll be conducting a paired samples t-test when you have two metrics, or interval or ratio scales, and no independent subgroups. So in this case, all respondents would answer to both these two metric scales. For instance, in the Marketing Management Week 2 survey data, participants rated their first impression of the course on a 1 to 5 scale, and then rated their impression of the course after week 2, both on 1 to 5 scales. The paired samples t-test would then allow us to compare whether these differences from before to after week 2 are statistically significant, as we can see here on this slide. It compares the means of two related measures of the same respondent. The prerequisites are that the dependent variables need to be measured at least on an interval scale, and obviously that every respondent in the sample has answered both of these measures. If we then go to SPSS to conduct this test, we can do so by clicking on Analyze, Compare Means, and then selecting the paired samples t-test. Then expand this window here, we can see that the test is asking us to specify within this paired test what is variable 1 and variable 2 that we wish to compare. And we can quite simply enter the rating pre, so before the course, as variable 1, and the rating after week 2 as the second variable. We could also add, if we wanted to run multiple paired samples t-tests, further pairs of variables that we wanted to compare. But in this case, we'll focus only on these two and hit OK. Look at the output. We can see that it's comprised of 3 different parts. First, if we look at the overall statistics, we can see that the mean of the course rating before the course, the first impression, was 3.49, and then it was 3.33 after the second week. This suggests perhaps a small drop in the course rating after 2 weeks, perhaps due to some frustrations also with the MRP project. And to determine whether that slight drop in the rating of the course is statistically significant, we need to look further down. But before we do that, it's good to acknowledge that in the second part here, we can see that the two measures in a test of correlations, and based on a p-value smaller than 0.05, these two measures seem to correlate, meaning that the ratings move together, and this is to be expected since previous ratings of the course, earlier ratings of the same person likely correlate or actually affect their later ratings. Then, to look at whether this slight drop in the course rating is statistically significant, we look at the last part of the table, and specifically the p-value here. The null hypothesis in the paired samples t-test is that the means are equal, and we can see based on a p-value of 0.016, that is smaller than the cutoff of 0.05, that we can reject that null hypothesis, meaning we can reject equal means, and we find some support for the slight decrease in the rating after 2 weeks.